Good afternoon, everybody, and welcome to this lesson of Archive Online Academy, the public training program of the Digital Center Archive of the Fondazione Giorgio Cini, inaugurated in 2020. As you know, Archive Online Academy include talks, courses, workshops dedicated to digital preservation and enhancement of cultural heritage and digital humanities in general. Today's lecture is titled Parcels of Venice and is led by the team of the Digital Humanities Lab of EPFL, founded in 2012 by Professor Frederick Kaplan. Alongside him, today we will also have Nicolas Mahmoud Gresci, Paul Keinec, Isabella Di Lenardo, and Manuel Ehrenfeld. I would like to remind everyone that your questions are very welcome, and you can type them in the chat and or raise your hand at the end of the lesson. And before leaving the floor to Frederick, I would like to remind participants that required a certificate of attendance that you can just follow the instructions written in the chat. And thank you for your attention and enjoy this lesson.
Good afternoon. Do you see my screen well? All good? Okay,
we
so
do.
It's a great pleasure to be here with you for this academy. The idea today is to give you in a bit less than 2 hours a bit of an update on a project which we are about to finish, which is called Parcels of Venice, and which has a series of output. One main output being a prototype of a research platform which has some interest for people doing research on Venice in particular. So this has been conducted at the Digital Humanities Laboratory at EPFL and also at the Time Machine Unit, also at EPFL. It's funded by the Swiss National Science Foundation, and it's part also of all the effort we do at the level of the Time Machine organization to develop tools that permits to study the past of cities and construct new ways of understanding their evolution. And I'm mentioning also our partner Econem in that presentation, because some of the data you will see today has been based on the large-scale point cloud acquisition, which they have been doing a couple of years ago. Oops, let me just go here. A couple of words about the program. So I will give you just a short introduction on the project and its main outcome, and then Isabella will present you essentially the way we've been processing a series of data sets and the type of pipeline that we're involved in order to extract important information to be able actually to see the types of results, which we have now on the platform. Then we'll move to Manuel, who will actually explain to you the logic of the interface, how it was built, the type of decision that were done in order to make the possibility of searching and navigating through this type of data possible. Then we'll move to Nicola, which will describe slightly more things related to the backend. How does it work server side, how to construct and replicate potentially such a system, and how to make it efficient and scalable. And then we'll finish with Paul, which will present his own research that he has developed in the group for his PhD thesis in particular, which was illustrating and how that type of data can be used to actually conduct some research on Venice. So, this is going to be a bit packed. We'll try to keep everybody within a kind of 20-minute slots. Of course, there's potentially more to say on all of this topic, but it's a good occasion for you to get in a relatively limited time kind of overview about where we are and where we're going. Oops. Mentioning also that, okay, we speak as 4 today, as 5, but actually it's a much larger project involving a series of ongoing researchers, also some which have contributed in the past, which have helped build since the beginning of the project in 2019, quite a lot of elements that you will see today. I also would like to thank the students which have been working on the project and throughout the various semester or master work are improving the types of research we're doing and enable us to explore avenues which we could not explore if we would just do it with our team. It's also a great pedagogical tool, as we will see. I mean, a good way to learn and experiment about this type of historical and urban data. To explain the project in a nutshell, I mean, one way to start is to say, I mean, that we have information organized in space in systems like Google Earth or Google Maps, but obviously, I mean, there's very little temporal depth. And so since the beginning of our research on Venice, we've been interested in trying to understand how it was possible to align information about the past with information about the present and the way we could do this. And one of the thing we were envisioning is actually the fact of linking like a 3D model of the city, like the one you see here, with information coming from photographs, which could be also linked with information based on cloud points, which also is possible to align on information that you have on paintings. And so doing so, each time you're actually traveling through time, changing dates, having the possibility of keeping that information fully navigable, going from the 3D model to, for instance, the Napoleonic cadastres that gives you information about the different parcels of the city in 1808, and progressively linking with document. In that case, for instance, seeing our particular parcel in 1808 could be informing that particular person, Francesco Raspi, was actually having a shop in that particular place. But actually making connections with potentially other forms of document here, the catastici, informing that another person from the Raspi family was actually also owning a shop on the bridge, which is permitting us to put it back at that particular place in 1740. And so little by little, making more and more links between all these very different types of document, we have the possibility of connecting and organizing a form of spatial temporal navigation. So that was the intuition, I mean, the initial intuition, but that actually took quite a lot of time to manage to connect this information with one another. And I guess you will have a bit of an idea of that effort today, but let me immediately jump to the to one of the representation we have now on the city, why we've been processing this different information. And you see it takes the shape of a map, essentially, where you could zoom, especially like you would do in any geographic information system, except that underneath you have a bar which is showing the temporal information available in time. And so if we focus, for instance, here on information which is linked with the middle of the 18th century, and we go on the Rialto Bridge, well, you find back actually Francesco Raspi, or Giovanni Raspi in that particular place, and you find back the document that I was just mentioning in the video just before. And it seems little, but that has actually took some time to be able to do that in a general way. I mean, not only for that person, but for the entire population. Which is described in this fiscal document. And so you can do the same thing, move your temporal slider going at the beginning of the 19th century, and as you may expect, there's another point you will see on the Rialto Bridge, and you find back now, I mean, the shop of Francesco Raspi, which is described in that other document, this summary. So this process, I mean, which is essentially connecting information which is in registers, in archive, and putting them back in space and time, enabling you very basically to say, I mean, can I actually have all the information which is available about a particular place in Venice? Is essentially the main, rather intuitive output of this interface, which is enabling you to essentially browse in a different way into that types of information. What you can do also is connect that with other types of document, which are, for instance, maps. I mean, you can have here for them the cadastral maps of the beginning of the 19th century, so always 1808, and again, have the two systems fully synchronized, going back as I was mentioning, to the Rialto Bridge, finding the alignment and see, I mean, how does the historical sources is behaving. That sources is not just an image, it has been actually segmentized, I mean, which is, we can see the parcel. We also have analyze the street network, which is enabling to do various type of computation. That means that it's much more, I mean, than just a single image. It's actually an information system which can be used in various ways. And what you can do, of course, to navigate in this information, if you're not only interested in just, I mean, looking at a particular place in a particular time and see information available, is search. And so one of the features of the interface is that you can just, for a name, of course, we won't search for Raspi as an example, and you will find, I mean, not only, I mean, the point we've seen on the Rialto Bridge, but actually many other places in Venice, which is corresponding to different types of ownership, which the Raspi family happens to have. Sometimes also linked with places they're renting, and so the same logic is there. You can go click on a point and check the sources if needed to understand what it is about and what are the links which are there. You can also navigate, I mean, through what we call a list of points of interest, which you have on the right. So this is a rather intuitive system. You imagine, of course, that it is very powerful. I mean, if you actually want to study a particular person, I mean, you will find immediately all the links, I mean, you have of that particular person based on the document which were analyzed. If I'm moving now to another example here, I mean, the thing we can also do is represent the information not only in 2D, but also in 3D, because of course, if you're not knowing Venice very well, I mean, the other type of representation may be a bit abstract. Also, it lacks completely other form of understanding that we have, in particular with 3D model. And so another possibility is just bringing essentially that information back, a bit like what you have on Google Earth, essentially, except that you have all these white dots, which corresponds, which are floating on top of the city and which correspond to all these basic information, which is available, and that you can just browse, search exactly in the same way you're doing in 2D. So depending on the moment, I mean, you can switch from the 2D or the 3D version. I mean, bringing back some context or having a more, let's say, abstract representation if needed. So all the information you see here, I mean, it's about 50,000 points, which now have been extracted in Venice, which is making it a very, very dense system. But despite, I mean, all the work which is done here, I mean, the entire, let's say, the system that we see here is actually generic, and you can, without problem, using it for other places, other city in Italy, in Europe or elsewhere. It's essentially just a matter of registering them in the spatial temporal grid that we are organizing, and then you can just start to populate other places in Europe with the same logic. So here I'm just zooming on one of our next importation target, which is of course the city of Lausanne, where there's a lot of work which has been done, particularly by Isabella Di Leonardo and her team, and which will soon be filled with points here. So we enter, I think, an interesting milestones. I mean, it's still, I mean, we still need to do some testing. It's in particular linked with scalability. I mean, one thing is to work in the type of environment we're there. Another thing is to be able to work with a larger number of students potentially. And of course, I mean, being capable of having all these systems which are scaling to thousands of users or more. I mean, it's a bit challenging, and we've been doing some form of stress test over the past weeks, which would need a bit of of refinement, but I think we had the good situation. Same thing regarding stabilities, quality control. I mean, of course, one of the very interesting aspects about this type of system that you discover errors in the model or system that you can correct, which are much more visible than in other types of representation. We're also going to work on more flexible collection management system to deal with situations where you have distributed data sets in particular. And one thing which is almost ready, but not fully included in the current prototype, is the way in which you can actually export the data set which you are currently seeing and analyzing in order to do other forms of let's say analysis. And also very important, having a system in which will enable you to cite the particular data sets and the particular sources which are implied in that system. So all that, I mean, needs still a bit more time, but I mean, we're in a good situation, and we thought it was a good idea to give you a bit of an update about the current state of advancement. So without further ado, let me switch to the presentation of Isabella, where she will enter a bit more into the actual processes that permits to link the document with the type of data you've been just seeing. Let me just switch slides.
Hello, hello everybody. So let us quickly present some of the sources from which the information has been extracted that you will be able to access in this web interface that we present today. And that will be also illustrated by my colleagues, Manuel and Nicolas. And what are these type of sources that we try to aggregate and to explore in the web interface? Essentially, they consist of mainly of textual, visual and cartographic documentary sources such as census and cadastral data, directories, historical cartography, historical photographs, ancient postcards, and secondary literature too. For the sake of time, we give an explanation of the censuses and cadastral data and the directories today. Directories are the forerunners of the yellow pages. The census data and the cadastral data we have considered cover a time span from the late 16th to the mid-19th century. Essentially, there are surveys whose historical framework I do not describe more today for limit of time, but that map essentially the situation of land ownership in what we might call the ancient regime, so before the fall of the Republic, of the Venetian Republic, and then the modern period, so after the fall of the Republic. These sources are particularly accurate and allow to reconstruct a comprehensive view of the property ownership, functions, rents, and in some cases, even tenants, as in the case that we show here, so the Catastici series. The documents are compiled at a precise moments in the evolution of the Venetian history. So they concretely looks like time frame of information, and the coverage you see here in this slide. In the case of the Catastici series, for example, there are door-to-door handwritten surveys in which the inquirers follow a fairly continuous path in the city and try to survey key elements as, for example, the place name, the urban functions as for describing more what they are seeing, if they look at bottega, so a workshop or a shop or storehouse or houses and so on. And then the tenant of this good, and then the owners, and then in many cases the rent, so the income. It is possible to georeference each textual record to a precise place thanks to some key elements, such as the place names, that following the continuity of the paths established by the inquirers. Among the census and cadastral series after the fall of the Republic, there is the geometric cadastre that you see here in this slide, as well as in much of Europe, introduced as a result of the first French and then Austrian administration in Venice II, in which there are records with textual land information and the land plots showing the information on the maps. In this case, geolocalization is even more precise because it can be done at the scale of the individual building, so at the scale of the parcel, through the presence of the numeric parcel identifier that links each parcel to its corresponding geometry on the land plots. Therefore, it was necessary not only to transcribe the textual documents, but also to proceed to vectorizing the geometries on the maps, extracting the numbers and the text of each parcel, to tie the two pieces of information together. So essentially the number of the identifier on the left of the screen that it's recorded in the register, and then the number that links this information to the parcels on the maps. But as one can easily imagine, however, creating a database of this information requires structuring and classifiable and standardized text. Instead, the text, although more or less responsive to the fine needs of the administration, contains several disturbing elements, as the fact that owners are not always explicitly separated by standard delimiter, last names are something missing, or they are related to other symbols, text is missing or substituted by sudetto or idem or other type of language elements. Parcel entries contain all sorts of additional information about owners, also in terms of relatives, for example. This is very, very precious, but it's, of course, it's very difficult to standardize. And then for this, we need to normalizing names and locations, try to apply uniform rules for each entry, handling different spellings of Venetian names. So this is a very huge task. Try to categorize owners by type, for example, in case in which we have the mention about their social status, so if they are aristocrats or not. And then we need to take in consideration the fact that we can establish a family name dictionary comprehensive of all the name variation spellings, and even for the place names and even for the urban functions. We can summarize the methodological approach in this pipeline. It's not exhaustive, unfortunately, but because it's so the process, it's very, very huge. And essentially, we try to consider two types of documents. The first are typewritten, the second one handwritten, and they follow two different paths of methodology, especially at the beginning of the pipeline. The things are quite different, because for the typewritten documents, we need an image pre-processing approach. And then more or less, so they follow the same path that we go through a manual transcription in the case of handwritten documents, and automatic OCR in case of typewritten documents. And then we need to structuring the information, and we do this through semantic annotation in the case of OCR, and field extraction and definition in the case of handwritten documents. Something wrong. Okay. Many times it's reserved for the quality control and validation through manual check, essentially. And then data standardization, this is a very, very huge task, but it's important because instead it's impossible to produce statistics, for example, or to understand phenomena. And then, of course, try to classify the information. This is particularly important if you need to identify persons of place names that are quite similar but not exactly the same, or the name of institutions that can be also spelling in a different way. So we need to also normalize and then classify this type of information. And then, of course, another interesting possibility that we have in the pipeline is that we can enrich this data through the Wikidata linking, for example, or through the possibility to add more meta classes to our information, in the sense that, for example, in the case of ownership, we can add information about professions, or even for directories, we can add classes about the functions. So essentially, we can add classifications, and we can add other layers of interpretations to the original data extracted. Of course, a big issue is the geolocation of all these elements on the maps. In the case of cadastral data, we proceed through machine learning methods that are already published online in various papers. And we do essentially this methodology for doing both, so for extracting geometries and also for extracting numbers and tags, because there's not only numbers in the cadasters. Of course, the geometries and the transcriptions were then rechecked qualitatively manually. This allowed for the complete 1808, for example, cartography with all information extracted and to access to the original transcription and normalized field. And this is what you can access in the web interface, because all the special layers that have been extracted from the historical cartography have been included as explorable virtual layers in the interface. In this case, so in this slide, when we are searching for data related to the Napoleonic cadastre on the map, we see the vectorization of the plot that is accessed directly. And of course, you can also access to the textual records of each transcript and additional fields. Directories are, I said, the forerunners of the yellow pages, very, very interesting source, popular in Europe and United States since the 18th centuries. The first in Paris dated even before, at the mid of 17. And they providing access to information not about properties directly, but about activities, functions, and services located in the city. We extracted only a few books that were available online on open access. Following the pipeline, a textual database was created. In this example, you see some extractions related to the professional lawyers in 1857. And we have geolocated all these elements on the maps. I cannot give an exhaustive explanation of the geolocation heuristics, unfortunately, today, because this is too detailed and a complex methodology. It's enough to say that the house numbers were referenced by comparing at least 4 door numbering systems in Venice. The first was introduced with the Napoleonic cadastre, then the other one extracted from the Austrian cadastre, and then the first structured street directory in the mid of 19th century originated from the Combatti street directory, and then that of today. Geolocation allows for multiple analysis. Here, for example, we are highlighting some statistics based on certain macro classes of goods and services and analyzed according to districts. Some similarities and differences between these macro districts already stand out, like, for example, in the case of San Marco and San Polo, that has some liberal professions and luxury items and the presence of antiquarians, for example, and in not exactly, we don't see the same trend, for example, and not exactly the same in the case of Santa Croce, Dorsoduro, and Castello Sestiere. Historical mapping has an important space in the interface. Different background layers can be loaded to see the evolution of the city, key maps from the 19th century, which were available in open access through the IIIF protocols, and from some international institutions such as the Bibliothèque Nationale de France in Paris or the Washington Library of Congress in US, were georeferenced. Recent approaches allowed also to extract and vectorize text segments in the maps as well. This is very, very promising and interesting because allows to enrich the interface for point of interest that contains place names of specific maps. As we could see, toponym is not fixed, but they undergoes in constant evolution in the history of cartography, and this information layer will facilitate many further studies in this respect. Now, an important aspect related to the data production and traceability. For each dataset, the methodology is traceable and informed through the documentation provided in the GitHub repository. From the interface, one will be able to click on each dataset and access to the corresponding page in GitHub. Note that in GitHub, we also provide the Jupyter notebooks that enable some steps in the pipeline, such as standardization, for example. In each GitHub, it is possible to access the dataset in simple transcription as it originally appeared, or in its version with added fields. In addition, notebooks allow anyone to reprocess the extracted information to, for example, try to improve it. As mentioned by Frederic before, another important aspect is tracking and citing authorship. Many times the data are available online, but it's not really clear how to reference them in other publications. We have provided in the interface to be able to cite both the material authors of the transcripts, if manual, and the authors of the dataset through publishing each dataset in the Zenodo repository. All datasets are open, available under different formats and accessible via classical open data platforms. Among the next development actions that we plan to provide, there's the providing to an access API and to be able to aggregate other datasets produced by other authors, for example, in other research contexts, which will then retain their citability and authorship. Therefore, if you are interested in exposing them in this interface, please contact us. Many thanks. I give the floor to Manuel, right?
So thank you, everyone. I will try to do a brief overview of the design aspects of the interface we are building. Let me just reduce this. Okay, perfect. So, yeah, designing a scalable interface, the Venice use case. Basically, the interface needs to answer this question: how do we enable users to navigate fluidly between different scales of information in time and space? So these are the most complex things that we are facing in this scenario. For example, we need to go from macro views like the whole city of Venice to the micro detail, as we saw in Frederic's demonstration, so individual data. How can we do that? we need to handle the data management, handling a dense amount of data in a performant and transparent way. The transparent way is here super important. Every point on the map interface is traceable back to its historical route. So in this case, we are clicking on a baker shop in San Marco, and then we can click on the point and go and directly check on the document exactly the place, this reference, and go back. So this is this constant switching between macro and micro data handling is one of the most difficult things that we are facing on this challenge. Then we, for example, in this case, we are going to see how to deal with different data sets. So we are now removing some of the data sets because we want to focus on one specific containing some photography. And so in this case, I can also navigate and see this information through the map navigation. So this is one of the latest additions we did to the interface, the ability to place photographic documents. Then always in the same under the same data management feature, we are handling many maps and many vector layers. So we can, of course, choose a historical map, and then from there select all the vector layers that are contained into that to that map. And of course, we can navigate this in 2D and 3D. So this is quite difficult to achieve technically, but for the user, it's I will say quite accessible. So there is no much technical knowledge or skill required to discover and to read this information on the interface. So this is one of the interesting points. The second challenge is the user accessibility. So again, here we have a sort of two target audience. We need to make historical data accessible to both specialists and non-specialists. And in this case, we are trying not to lose any information or the richness of the information in this process. So even if, for example, you are just browsing your family name, or you want to check something related to your personal history, you can do it. You can search through the interface. You can access the same data through different interface features. And if you are instead more focused on you are doing some research, or you need more advanced tools, you can do that. You can go from the search to the time slider, where you can expand it and you can do more accurate research. Also, what we are seeing here is here is the expanded version of the time slider. The other thing we are keen on developing is the accessibility. So here we are seeing the dark mode of the interface. So the user can decide if they want to navigate in the light mode or the light or the dark mode of the application. Again, this could be useful for someone using the interface intensively. So it could be a nice feature. Also relating to user accessibility, we wanted to display 3D information. So you can, if you don't know well Venice, you can rotate the map and everything will work in the same way. Or you could either turn on the 3D buildings. So you will get a better overview of the city. Okay, so here, yeah, there is some navigation. And yeah, this is more or less similar to what Frederick was showing on his presentation. Then the third challenge, which, yeah, I mean, right now the whole application is focused on Venice, but the idea is that the application should be able to scale to many other cities. So we are working in a way where things can be interchangeable. So yeah, whatever happens here in Venice should be available also in many other cities. And at the moment, the application is working well on this direction, and yeah, everything is scalable. Then one thing, yeah, this is a little note on the design approach. Since this started as the Venice case, but should be scalable, we, in parallel, since the very beginning, we started doing a design system. And with this modular design approach, every component we are creating for this project can be reused on many other websites or many other versions of the same interface. So this is important from a design perspective. Then the other super important thing is that for this kind of projects, of course, we need to take care of about accessibility. And we prioritize accessibility since the very beginning. So we want to have a responsive design, ensuring that the interface adapts across different devices. This is like a common case for most web design projects nowadays. But on this type of specific research tools, it's much more complex. So we are heavily working on this in order to make this application available even on your mobile phones. Then, of course, keyboard navigation, accessibility. We are working, putting all the area levels to improve screen reader support. And as we saw before, the light and dark mode to help people with visual sensibility. So this is all regarding accessibility. Here we can see another, yeah. So yeah, here exactly the same features that you are seeing on the desktop application are available on the mobile version. And one last word regarding the front-end technology that we are using. For us, this is super important. We are working with open source technologies. Concretely, we are doing a server-side rendered application. It's built in Vue and Next.js. Those are front-end frameworks. The architecture is decoupled, so we have I'm taking care about the front end in this case, and there is Nicola working actively on the back end. So those two things are independent. On the front end, we are using TypeScript. For the maps, we tried many different technologies, and now we are quite happy with DuckGL. It's super performant. For the AAAF viewers, we are using the classic OpenSea Dragon. For the infographics, for example, the time slider you see at the bottom, we are using UnoVis, which is based also on D3, I guess. And for the accessibility, we are using an unstyled library called RadixView, which is super good because it's battle tested in regards of accessibility. So it allows us to bring 100% accessible while keeping the possibility to apply our custom design. So whatever we want to do, we can. We are not tied to a specific UI framework, for example. So this is the best of both worlds, because we can do whatever we want, but the components are already accessible and tested. So this is everything, I guess. Yes. I don't know.
Now to Nicolas to see a bit about the backend. So that was all the front and all the, I mean, it makes such a project you need. I mean, of course, as you see, various competence and skills. Now we're going to explain a bit how it works from the inside, let's say, looking at the system architecture. Again, this is important from a perspective of we want the system to be reproducible and work in other situation than just Venice, and making sure it's all based on technology that can actually be sustained and be stable and scale in a global way. So the floor is yours, Nicolas.
There we go. Thank you, Frédéric. I hope you can see my screen. Nice. All right, so I work as a full stack developer and a system administrator at the EPFL Time Machine unit. And I'm going to try and give you an overview of the complete system architecture and specifically of the backend of the Time Atlas application, and try and give you the gist of how it was designed and how it works. All right. So we have seen the datasets we are working on, and we have seen the end results, the web application as it looks like in a web browser. So how do we go from those datasets to that end product? So first, here I have a few steps we are going through to get to that nice result. First, we have to prepare the data in order to integrate it into our backend application. So to do that, we have defined a few standard JSON files formats, and we prepare the data. It's a data science step, let's say, where we transform the file that are prepared depending on the data set into a standardized format using GeoJSON and a JSON file, or exclusively JSON now. And then we integrate, we ingest those files into our system. So this step will include storing the data into a database, indexing the data to make it searchable, and caching as much as possible to make the whole application as performant as possible. And then to make that data accessible, we need to provide services, APIs, which will then be used by the web application that you have seen demonstrated before. And that's how they communicate. They are completely independent one another. The backend application just takes care of making the data available through the APIs, and the front-end application just need to use those APIs to get the data as it needs. So what are the kind of services we are providing into the Time Atlas infrastructure? We are relying on several open standards that are already widely used in this field. For example, for the images, we are heavily relying on IIIF, both the presentation and the image APIs, which are the standard ways of storing and making images available for this kind of project. And for the geodata, we are mostly relying also on standards like MVT, which is Mapbox Vector Tiles, or WMS, WMTS, XYZ, and other standards that are already defined by open consortiums and various institutions that works on that. For the 3D data, The one standard that we are relying on is GLTF, which is a format used to provide information about 3D data. And this is the format that is used for the 3D tiles that you have seen, the 3D view of the whole Venice city. So those are the, the format that are already available, the standards that pre-exist. But for our own usage, we need to define our own specific standard because we are defining a way to structure the data and make it available. So in order to do that, we define our own our own API. Can you see my browsers? Yeah, okay. So we define an API using a standard JSON schema. And through this API, through this documentation here, anybody can see how the whole API is structured and how you can interact with it. So you can see how to send requests to the application to get specific information depending on what you want to display. And you can see how to format the requests and what kind of information you get back from the backend application. All right. Now that I have, oh, and I forgot about the web annotation data model, which is also a standard, which is used to define how specific information in our system, like a historical record, is connected to another resource in the system, like the page in a document. And this is what makes it possible to go through a record on the map to a specific page on a historical archive source. All right. So now let's see an overview of the architecture of this system. Oh, sorry. Okay, so through those different services here at the top, your web client, your web browser is making requests to a web server, and that web server is handling the requests and passing them to the framework we are using, which is basically the whole application. And this framework is then, depending on what you want to retrieve, using the search index or directly the cache it has already built to give you back the data. It is connected, of course, to a database where the data is stored. And that same database is also connected to a GeoServer, which is providing the GeoServices that I have presented before. This makes it a whole system with a single source of truth. So what you see on the map is also what you will see in the search results. So this is an overview of the complete system. And this is how we have the tools we have chosen for implementing this solution. And those could be different tools. I think it's important to insist here on the fact that we want something that is modular as much as possible, where we can replace some bricks with different ones depending on the need. And because we have a standard API that is defined, anybody could implement the same system differently should they want to. What we have done here, I'm not going to go into too much detail, but I think it's important to know, as Manuel has already said, that we are focusing on using open source, free and open source solutions as much as possible. For example, or actually all of them are open source, the ones that you can see here. And we are using also a framework, Laravel, which is quite easy to use for web programmers in general, which is not too focused on a specific field. It's a very generic tool. Same for the other solutions we have chosen. And another thing which is important is the database that we are using, PostgreSQL, which has a very powerful extension, sorry, a very powerful extension for geographical data processing. All right. So now we have seen the generic architecture of the system and the tools we have chosen, but there are many different ways to implement this solution. The one we have used for the preparatory phase, the first research phase, let's say, is a solution with several virtual machines. Sorry. So we have been using virtual machines on which we have deployed Docker containers that make it very easy to deploy a system while it's being designed and we are still developing it. We can copy and add and remove Docker containers very easily. And we use a Docker container management system, Docker Compose. And we use also a scripted deployment, which means we can easily replicate the whole system by using some scripts. Finally, we have also several monitoring tools available to try and see if the whole application is performant enough for our needs and will scale efficiently. So this is the setup we have been using at this stage. It looks a bit like this, but I'm not going to go into too much details here either. But basically, we have the various virtual machines with the different services, and you can see a bit how they interact together. So this is a current setup, but the one we are working on at the moment is a re-implementation of the whole thing. Instead of having several separate virtual machines, we will have what is called a Kubernetes cluster. And sorry. So a Kubernetes cluster is a way to manage containers as well in a more efficient way, and in a way that we can very easily increase the size basically of the system in a horizontal way, which means instead of having a single Docker container for a specific service, let's say the web application or the cache, we can easily create as many containers as we need, which means with the ambition of the project, which is to go to focus not only on Venice, but on much more cities in Europe and beyond. With a system like this, we can very easily support much more traffic and much more complex requests. Another interest of this system is that it's very easy then, as the whole deployment system is defined as configuration files, it is very easy then to reproduce the whole system. And as it will be completely open source, the container images will be public. It will be possible for anybody to try and reproduce the whole system wherever they want on their own cluster, and then to make the various implementation communicate with one another. which is the end goal. All right, that's it for me. Happy to pass the floor.
Thank you, Nicolas. So we are passing from a technical aspect to others, but I think indeed, I mean, the message is the following. I mean, it's very important. I mean, all these effort to actually create some resilient structure, which will actually be manageable in the future. So there's a lot of effort which is done. I mean, on the research side, a lot of effort which is done on the actual processing side, the curation side, and so. It's very important that we maximize the chance that this is actually sustainable. I mean, in the future, hence, I mean, the different choices that Nicolas has presented, and the fact also of being extremely open about the different technology. It's also a way, of course, of calling for improvement. I mean, if there are people which are wanted to actually say we are wrong in the use of a particular technology, of their ways of doing it better. I mean, that's the whole idea of this open approach. But back to Venice now. I mean, now that you understood, I mean, on the one, the generosity, it's also important to understand, I mean, how the effort which is actually done on processing, aligning, structuring data can then be used in various ways to try to deepen our understanding about the city. And so here, we could have, days of presentation regarding this, but we thought it was a good idea to give the floor to Paul Guyenes. He just actually successfully defended his PhD thesis, which is precisely on that topic of using that type of information to try to explore and develop new understanding about some aspect of Venice. So, Paul, the floor is yours.
Thank you, Frédéric. Thank you, everyone, for being here. As Frédéric said, I'm tasked with the wonderful opportunity to present to you the actual research output that came from this series of operations that the lab has been working on for the past few years. This is wonderful. This is also very difficult because, as he said, I only have a very limited amount of time, and of course we could talk about this fascinating city for hours. But let me start with a few images. And in particular, one object which has been the core focus of my own doctoral research, which just concluded. Frédéric alluded to it in the introduction, but we do have a unique resource to capture the architecture and urban structure of Venice, and this is what you see here. This point cloud, which was obtained in 2021 using drone aerial photogrammetry. When zoomed in, it looks like this, and already it's quite a stunning object to be manipulating. But with such a complex object, we've got, of course, many questions that arise. The first of which being, of course, how do we manipulate it? How do we interact with it? And then the subsequent questions being, how do we start to make sense of it, and how do we integrate it into an historical inquiry? Which I think many of you might be interested in as potential users of our platform and datasets. I'm not going to go into any technical details because this is way past our interest today. However, I can detail that one of the solutions we've tried to implement is to think of the city notably as a collection of units, typically buildings. So when extracted from our point clouds, one building, let's choose the central one, looks like this. Computationally, and Isabella has been talking a lot about it earlier, but computationally, this is nothing but a set of data points. And of course, the challenge here is how do we go from this 300,000 set of 300,000 points to its visual representation, which you see on the left, and in particular to understanding that this data set represents the Basilica of Santi Giovanni e Paolo. This is the whole idea of integrating those many different data sets that each cover a different subset of the information we have about Venice. The first thing we can do is simply look at streets and waterways. And what I mean by this is by starting to interact the point cloud with streets and canals, we already can reconfigure it. And I'm showing you here one example. It's quite technically easy to extract from the point cloud all of the facades of the city and then choose only the ones we want to show, in this case, the facades of the Canal Grande. However, as a starting point for inquiry, we do not, for example, consider them in their geographical position, but rather in using a different criterion, in this case, height. And already we can see that we can nuance our idea of the Canal Grande being exclusively the seat of aristocratic palace facades, and moving on to containing some more nuanced typologies of usage. But because this stems from a computational structure, the ones that we've been detailing today, it's simply, it's quite possible to have the same sort of representation for a different street, perhaps less studied than the Canal Grande. Here, taking as an example, the 1930s district of Santa Marta, extracting all of the facades in the southwest of the city. And here, the remarkable typological consistency of the area strikes the eye and perhaps opens questions. Okay, so right, so at this stage, we can align our 3D models with streets and canals, but we want to do a bit more. And to do that, we can leverage all different layers that we have talked about, different sources. I'm here showing you actually another one, starting with an open database such as Wikipedia. Venice has obviously a lot of mentions on Wikipedia, but what is it exactly? Well, we can extract that using the sort of API query that Wikipedia has put in place. And we see quickly that it only covers about 8% of the city. If we want to represent that, we can overlay the two, and this is what it looks like, which is slightly disappointing for someone who might want to study the whole fabric, as we can using our 3D model and our different sources. This is where we turn our attention to the other layers that Isabella presented. Typically, those early modern or later administrative surveys and censuses that take a series of administrative snapshots of the city from the early 16th century. And this gives us information on every footprint that there is, and potentially on every building that we have. So as Isabella detailed, we can reposition this. This is what it looks like for the Catastici and the Napoleonic Cadastre. And with each of those geometries comes information on usage, name, owner, typology, etc., which we can then cross-interrogate with our 3D model. Other sources that are very great values is that which is found in local archives, such as, of course, the one here at the Cini. We've been digitizing for the past few years the Fototeca, and in particular, we can realign the architectural photographic collection, which amounts to about 10,000 images. We can replace them in space, and as Manuel showed briefly, we can already reposition them in space and then click through the different images to see different facets of the same building, interiors, exteriors, etc. As an example, I'm taking here the Palazzo Michel delle Colonne, which was built by Antonio Gaspari. This is what the cardboard looks like. But as we start to create our information system, as we start to build our interface, well, we have different pieces. So we've got maybe two different images, the original project, 20th century photograph. We have as well the 3D scan. We might have information from Wikidata, etc. And we can start to overlay one with another. Typically, in this case, I'm showing you what happens if we reproject our 3D model onto our sources, and evident is the fact that the original drawing by Gaspari has been slightly altered in the attic. Okay, now on to some case studies that are very close to what you might be able to do if you use the interface we've been describing today. The first of those case studies concerns the structure of the city itself. It's something that I've been quite interested in for some years, also because it follows a long tradition of history of looking at those urban structures. But what I'd like to insist on is that through the data sets that we have curated over the years and the way we've structured the information, we can start to ask questions that up until now simply couldn't be tackled. And I'm going to try to convince you of that. So if we take the street network of Venice, we can convert it using some mathematical operation into a proper topological network. And with this comes the automatic identification of some strategic points. Think of it as the streets that one would naturally roam to or use if we were to cross the city in the most efficient way possible. For those of you who know Venice very well, you probably recognize streets you use every day, especially around the Rialto, which is the topological center of that network. It is perhaps not a coincidence, considering Rialto has been the socio-economic center of the city for at least 1,000 years. Also interesting is how, from this center, a few avenues emerge, or radiate, rather. We can see that some, and I've highlighted them here in red for the most important, in blue for the secondary, how those limited set of streets actually attract most of the flow. Okay, right. So this is quite interesting in itself, but of course, this is talking about the city in the 21st century. And as Frédéric opened the presentation with, what we are able to do with those massive digitization is to open up the study through time. So what happens if we use those street networks that we have extracted from the early 19th century and compare that to what it is like today? In the case of Venice, it's particularly interesting considering that so much has been happening over the course of the 19th century under the Austrian and then Italian rules, with the creation of new streets, the building of new bridges, and covering of some of the canals, turning them into streets. This is what I'm showing you here. And alas, time doesn't really allow me to fully develop this idea, but in blue, you can see streets that have had their center of interest, or rather their centrality, lowered relatively, and in red, places that have emerged as more central. Quite interestingly, we can see how through the construction, notably of the Ponte dell'Accademia, since the early 19th century, the area around San Marco has become more central. Okay, so what we have, if we consider the city as a network, is areas of preference, strategicness, as we can call it. It is, of course, very tempting to think of it as being also commercially attractive. And this is something that is often found in cities today. If you have a very central street, you're most likely to find shops there, as obviously there is an economic incentive to being central. But because we also have sources that exhaustively list the position of shops across the city, notably the 1740 Catastici, it is possible to replace this distribution of shops around the city. This is what you see here, and we have extracted almost 6,000 shops. And we can compare that to what I've just shown you, the cartography of strategicness. And indeed, it is quite striking to see that there is basically a one-to-one correspondence with very few exceptions. So we would tend to confirm perhaps an intuition that 18th century Venice aggregated its shops at strategic areas of flow. This is what it looks zoomed in on the area between Rialto and San Marco. Now, there are some exceptions to this. You might have spotted some in the previous image, although it went quite quickly. And this is, of course, because we might want to consider Venice as more than just a unique network. We know that it is structured, or at least was structured around parishes that formed the nucleus of the social life for a long, long time. But thankfully, through the analysis of other of the layers that Isabella presented earlier, other historical sources, we are able to reconstruct what those parishes looked like 200 years ago, something that really has never been completely achieved, because no official cartographic mapping existed and no exhaustive access to the sources was possible. But we have it now, so we can look at what the parishes look like. And dovetailing onto what I was saying just before, we can notice cases where the flow across the parish is more is a better explainer for the position of shops than the flow across the city. And those are some of the examples. Notably, Santa Maria Formosa is better explained by local movements, whereas typically San Marcola is perhaps more justified by the global flow. And then on the bottom right, you see one exception to this, which you might have noticed on the map, and the Ghetto Novo simply escapes this logic, of course, for reasons you might understand of isolating the Jewish population on its own. Okay, moving on, building on this idea, I'm taking you now to a second case study. We have repositioned those shops. It's already quite telling in terms of the city usage in the past. But what we can do by combining our 3D model with those historical sources is by, if I may say, giving them a face, giving them an appearance. What does the 1740 survey look like? This is possible, of course, because Venice has changed relatively little in comparison to other cities. So if we are careful, we can actually look at what facades are being described by this handwritten document. Here's an example. This time I'm using the Napoleonic cadastre, and what you can see are the different parcels that have been drawn on the map, but intersected or reprojected, if I may say, onto our facades that we have extracted from the 3D model. By being careful, we can reconstruct what bit of the facade is described by which bit in the text. So there's, in this case, and this is why I've picked it, a very handy combination of both storage space in green, lodgings in blue, and then this mixed use building on the left that you see framed in red that combines shops and housing. But if you look at the shops, which is what in this case study we're going to be looking at, you can see that we can understand what the shops being described in the cadastre look like. And in all of those cases, they are a combination simply of a door and a window. This was the beginning of a tiny, or actually quite a long inquiry for me, looking at what is the compositional typology. And here we're talking perhaps more in terms of architecture, the compositional typology or typologies of such shops. The door and the window is perhaps a simpler one, and indeed it is found in most cases, but there are other scenarios, typically, as you see in the center, one door with two window fronts, etc., etc. Now, this, again, could not have been done without the combination of those massive 3D scans and this massive digitization of historical sources. Another typology is, this time very limited in number of examples, is the one that is perhaps stately, where large-scale interventions have created a specific typology that of the arcade is combined with some political institutions. In the case of Rialto or San Marco is the most obvious. There are cases, however, where our 3D model is not suitable, and that happens if we follow this study of storefronts, considering that window blinds might obscure our view. And the reason I say this is because, well, there is a very convenient alternative to that is brought by the same logic that we try to show in the interface, and that is combining the documents. So if I click on this building on Campo Santa Maria Formosa, we can see its contemporary 3D appearance, but we can also see which documents in the collections of the Cini Foundation pertain to it. And in this case, I've highlighted a small section of an engraving from Canaletto that tells us what the typology of shops are in this example, which I then confirmed on site, thus allowing to deepen our investigation. Okay, let me see. Time is going, so let me move on a bit. I've tried to exemplify this idea of combining our historical sources with what they look like today using shops, using the function, but you can think of different scenarios, and perhaps some of you might be interested in other things, such as the facades of the properties of different families. I'm here showing you the top 6 families according to the Cadastre in the early 19th century, and I'm also representing you all of the facades of buildings they own. And perhaps this can be the beginning of other investigations. As a tiny toy example, I can show you that some possessions of the Priuli family, for example, seem to have striking resemblance between, on one hand, the seat of the family, and on the other, popular housing that was built by and for the family, resembling in terms of both typology and dimensions. So there is something here to say on the dialogue between the different uses of the same property or the same family. And on to our last case study, to just give you an overview of what it is possible to do through the interface, is what I've been calling in my research moments of rupture. Some of you may be familiar with a common metaphor that is being used for Venice, and it is that of the continuum, a perfectly uninterrupted landscape, something that you do already read in Francesco Sansovino's guidebook in the 16th century, but that idea has stayed on for centuries and is still being used today in architectural scholarship. However, as the Venetian walker might notice, in some cases, we do notice buildings standing out and breaking that continuity, that homogeneity of the fabric. To give you an example, I'm here taking 2 palaces. At the top, you see Capesaro, and at the bottom, Palazzo Belloni. You can see that the example at the top is clearly a rupture, right? There is about 14 meters difference with its neighbors, and the effect on the viewer is clearly one of distinction. On the bottom, however, the effect is quite different. It is one of perfect continuity, perhaps more akin to what I've been mentioning before on the continuity of the fabric, the fact that even aristocratic housing would like to blend in the otherwise so-called minor fabric. But the reason I've chosen those 2 examples is that they share the program, their architect, their date, and their positioning, because they're about 100 meters from one another. So there is something to investigate here. And the way we do this, or the way at least I've done it, but others might have different ways, is again to interrogate our 3D model with our other sources. So if we use the different sources, both the databases we've created, the historical documents, etc., we can identify all of the palazzi that are in the city, and we can look at how they blend in or not. This is the graph you see on the right. In red, I have highlighted the distribution of height differences between the palace's facades and their neighbors. And we can see that in most cases, they tend to be higher, perhaps expected, but in some other cases, they tend to be much, much higher, thus breaking the implicit ideal of a republic of equals that the myth of Venice tried to enforce, or at least to promote. We can further investigation by showing that this multiplication of buildings that break the continuity is not stable through time. And if we only look at Gothic and Renaissance palaces, most of them do not break that continuity, at least not significantly. And we have to wait for the Baroque, which is the graph you see in green, to find that becoming more and more common, if not systematic. So this points us to a moment, an interesting shift in about the 16th century, a crisis of representation in aristocratic architecture, to break the landscape profile or not to break it. But as I have opened my presentation with, one of the things we can do is to look at a bit more than just the well-studied palaces and churches, and we can look at the entire fabric, because our datasets and our tools that we have implemented allow this. Are there counterexamples that do break this continuity of Venice that are not palaces? Will you see them mapped? And then the answer to that is perhaps a bit disappointing or not, but there are virtually no exceptions. Everything that breaks that continuity is either religious or aristocratic, with a few exceptions in the 19th century when higher densities of housing required taller buildings and the regulations loosened a bit. If we want to further our architectural investigation, well, we can also look at what they look like, and this is what I'm showing you here. Interestingly, this is relatively fast forward to do, in the sense that it is just a matter of how you ask our information system to show those facades. So overall, I hope I try to convince you of the validity or the fruitfulness of the tools and ways of interacting with historical data that we have developed, both in terms of in conceptual terms and in purely methodological terms through our interface. And of course, this is nothing but a hope that you will also take the lead on some things that might be of interest to you. Thank you very much.
Thank you, Paul. So you got here with a bit of a quite rapidly some illustration of I mean, the interest of aligning information in space and time. I mean, first for exploring in a very, I would say, natural way, an intuitive way. I mean, what is available about a certain place at a certain time, and then for doing potentially things which are slightly more sophisticated, where you can actually find other types of calculations, understanding, analysis, bringing at the heart of all this potentiality, the fact that you've been able to create this alignment, identification of sameness throughout time. So maybe it's a good moment to open for questions that can relate. I mean, we've been covering a 360-degree, I think, series of topic here. So I guess the floor is open. So who would like to?
So, if I might ask a question. I'm sorry, can you hear me well?
Yeah, we hear you. Yeah, very good.
So I have a few questions, but maybe I will ask only 2 or 3 of them. First, you say in the conference that you started to make this program at the year 100 and 1000 and 182. So before that date, it wasn't possible to do so because of the lack of informations and of data. Because if you started the program in order to register only from this date, so 1582 to 1842. So before 1582, it wasn't possible to do so because of the lack of information or no?
No, it's not impossible just because we have access to this, only to these sources. And so the first document, so the first survey of the city of Venice that we can document is dated at 1514. And it's a sort of redocumentation, the something that happens. So the first survey, but even the historians are not sure in this respect, but probably it was the first, it was taken at the end of the 15th century, but unfortunately a fire destroyed completely the archive in which this first survey was stored in Rialto. And in 1540, the administration provided another survey in order to fill the informations that they have lost in reason of this fire, and they redo this survey in 1514. Unfortunately, we have not access to this catastico, so to this condizione di decima is the Italian name. But of course, it's provided in preserved in the State Archives of Venice, so you can access. Of course, it's open, so it's not published online, but it's of course it's open. And then we have access to the 1582 from the 1582 catastico information and to this snapshot, essentially 1661, 1711, 1714, and then the first geometric cadastral of the city dated 1808. So if you talk about censuses, the records, unfortunately, we have to start for the city of Venice from the beginning of the 16th century. It's not possible to retrace surveys before this date. This is not because we didn't. Essentially, it is because the sources are not provided, so are not are never been produced by the Venetian administration. Then there are several sources of other nature about ownership in Venice, pointing essentially other type of archival documents, and this is something that we can retrace in this in the main work done by Dorigo Vladimiro. This is something absolutely huge in terms of information, in terms of knowledge about the medieval part of understanding of ownership in Venice, and it corresponds to a secondary source that try to recollect many elements from many different archival series about the city of Venice. Of course, it's always an interpretation of historical documents instead of survey that are a little bit different, because in the survey you see what the administration provided in terms of has a sort of neutral elements. So we just transcribe these elements. So there's no other layers of historical interpretation. So this is the reason, because for concerning the ownership, We have this skeleton, this bones about the census data that starts at the end of 16th century.
Okay, thank you.
Yeah.
Considering also these hardware, Mr. Ehrenfeld has said that it has been based on open source. So if I have understood well, is it possible in the future to participate between brackets to the modification or to the enrichment of this kind of system, just like I don't know, I was thinking about Ubuntu, Kubuntu, that indeed are open space programs. So is it possible in the future for customers or for researchers to increment, to enrich this kind of program because of this open source nature?
Yes. Well, all the tools we are using are open source. At the moment, the repository is closed, but it will be released. So the answer, I think, is yes, absolutely. That's the whole idea, and also the design system could be a facilitating element to other institutions to work with this type of things. So yes, from my understanding, absolutely.
Okay, thank you. The last question is dedicated to Mr. Guenek. So you said that you have done the street maps and also the maps of the canals, but is it possible to differentiate the canals that initially weren't shaped as canals, and also many streets in Venice that originally were canals that through centuries has been loaded with mud in order to transform them in streets or in orchard or in places in order to build monuments?
Yes, absolutely. In fact, some of our information system, part of it encodes that. So obviously it's also stored in the toponymy of the place, but Rio Terra being the ultimate example of a canal that has been transformed into a street precisely through filling and mudding. And then the first after the question about the change of shape of canals, is that right?
Yes, because some canals initially weren't shaped because they were part of the lagoon resort. So people used to go there with their gondola or their boats, but in the cadastre they were not recent as canals, only piccolieri or whatever.
Yes. Yeah. So any form of, sorry, what I've been calling canals is actually any form of water transportation. So it includes the riz, the piccolieri, etc., etc. So it's all encompassing that.
Okay, thank you very much.
Welcome.
Other questions?
There is a question in the chat about the documents, and Jose asked about the historical calligraphy. If historical calligraphy was not easy to read or understand, how did you put it under search button, or did you leave it out?
Okay, so there's two series of document or collections of document we should consider. I mean, the one which were actually used for getting a full view of the population of Venice, so the catastici, the cadastres, and for that we had to cover the entire population. I mean, we could not just subsample the things which were easy to read, and so everything was checked manually or transcribed manually if needed. So we are sure that for the 1741, for instance, cadastici, or for the 1808 cadasters, I mean, every parcel is transcribed and has been checked manually, which is a colossal work, which took years actually, but it's necessary if you need to count. I mean, any of the statistics which were presented either by Paul or by Isabella, which can be drawn, I mean, needs to be based on the fact that we have a confidence that the entirety of the collection has been transcribed. So in that cases, there's nothing is missing. I mean, there might be still some errors, but it's all been checked. There are other types of sources where it's to some extent okay to not necessarily transcribe everything, and for which progress in automatic transcription is very interesting, and that enables indeed to have a search situation where you look for a particular document mentioning someone, for instance. But in that particular cases, we have no then guarantee that the fact that you don't find that particular name is not necessarily present on the in the archive. So there's usually two steps. I mean, one is giving access through automatic analysis and without not necessarily, I mean, doing the second step if it's a type of collection for which exhaustivity is not mandatory. If exhaustivity is mandatory because essentially you need to count or you need to represent on the map, then there's no other solution than actually checking everything by hand. Other questions? I see if there's another one also on the chat.
From Francois. About the patere that are, I don't know, Paul, do you know the patere? Yes, that we can, because it's for you. This do you see the question?
I do see, yes.
Okay.
I think, I mean, the question seems to be on the practicalities. If provided we do have the information on the patere or the formel, could we add them to the interface? And I'm pretty sure the answer is yes. If we store them either as a simple text information saying this facade has a patere somewhere, or if we actually have a picture, yes, we could store this. Does this answer your question?
For the moment, they are not included. But there's nothing that prevent, I mean, the inclusion, yeah.
And then there's a second half of the question, what is the projected date of completion for this online research tool?
Yeah. So this is this year.
This month.
I mean, we always. I mean, I think we reach a level where I mean, I mean, everything is kind of working well, and so we're kind of happy with the prototype. It's still a prototype in the sense that it needs to be a bit stress test. I mean, again, in terms of, as I mentioned briefly, in terms of actual performances and other elements which distinguish what is a prototype to an actual element that can be put online. So we have a couple of things to still work out on this, but I think we reach a level of maturity which is pushing to doing it as fast as possible, but as slowly as necessary.
Yeah, we complete the first internal release, if we say, right, Manuel and Nicolas. I'm talking under your supervision, but we are doing some, stress test, what we call a stress test, because we see that it's quite different to try to have an interface for a couple of people or 5 people in a room. Another things is to open to a public that could have, I don't know, hundreds of users at the same time. So that's just another question in terms of infrastructure, not in terms of data structure or sources and so on, but just in terms of infrastructure.
And generally speaking, so one of the things we may like to do in the coming months or weeks, essentially, is actually gathering larger set of users which could perform some actual research as testers. I mean, before the actual full release. So we're kind of finalizing exactly what will be the form of that series of progressive, I mean, unfolding, where it's going to be, you know, a series of chosen beta tester, which can be a summer school or something. But that's essentially what we are working on to make sure, I mean, we solve all the remaining possible glitches and have the full quality control before we do the release. But I mean, we hope to do it as soon as possible. Other questions? No?
Okay.
Okay.
Maybe we can say one word about the fact that we are interested in keeping them informed about new events. Or,
yeah. So I mean, so stay tuned. I mean, we are. I mean, especially don't hesitate to write an email if you're interested in knowing more or being on these. Let's say early tester of the tools or any other elements that can bring ideas. If you think about some data that would be valuable, if you think of some use case that would be valuable, because that is also, I mean, part of the testing is also testing the relevance for a series of persons for research, but not only. And obviously, I mean, there's a lot of room for progress on that respect. So don't hesitate to reach out and stay tuned. We will in the coming weeks be a bit more precise about the calendar and the next steps. But we definitely need your help in making this final last miles before the actual release. Thank you to all of you. Thanks you also for all the organization for the Academy at the Fondazione Cini. It's I mean, it's always a pleasure to participate and I'm sure, I mean, it's a very, very impressive program, but also a series of resources. So of course, I mean, I guess most of you know, I mean, about it, but check it out for future event and also past event. I mean, there's been a lot of interesting things that are going on. And on that specific topic,
will be very soon.
We'll be again on the program with slightly. So today was a kind of self-contained exposure to kind of state of advancement of a particular platform prototype. But in March, we are planning 3 consecutive sequences, which take more the form of an actual hands-on courses. You want to say a couple of words about that, Isabella? Maybe?
Yeah, it's led by Paul Grenac, in fact, that is here with us, and me, and Frederic too. And it's concerning the back of the system, if we say this. So more detailed explanation and hands-on maybe practice exercises about how we can segment images, we can extract text, how we can reconcile text, typically, for example, place names with external knowledge bases, how we can realign documents and maps, and how we can publish it online, for example. So this is something that it's more about a sort of toolbox of coding elements that maybe can be useful in your personal researches or for other applications. But so we try to show what could be the tools for doing not all the extraction and the standardization of the information, but a part. In specific, we try to work on the cardboards of the Cini Foundation's small data sets of something, counting on something images for giving you the idea of what could be the concrete applications of this pipeline. So they're still open. The inscription, I think that they are still open. And if you are interested, please subscribe you. And we hope that will be useful for you too. Paul, do you want to add anything else maybe or not?
Well, I can say if you've got any questions on the content and wonder if this is suitable to you, please do send me an email. We can also make sure to use your data in the hands-on if you'd like to do that. It's a possibility. It's still open. So do contact me if you've got questions.
Okay, thanks to you all. Thanks to the presenters, and see you soon. Maybe.
Thank you very much.